This is my Lab 5 report. So for this lab, I analyzed the motion of a slinky, especially its bottom end, and then I compared my observation with the computational model built from GlowScript. And these are the physics principles I used for this lab. The Newton's second law, which is F net equals to delta V over delta T times m, and the gravity force, negative mg times j hat, and the drag force, negative b v squared times v hat. And I uploaded the video into Tracker. I set the coordinate system and the calibration stick and also the frame range. So the start frame is from the time when the bottom end of the slinky is just going to fall, and the end frame is the time when the bottom end and the top end touches the ground together. And this is the graph generated by the tracker. And here's the XY position data. And then I went to GlowScript. So I first changed the mass and the initial position of velocity, and also the constant g, j hat, and b. And there are two while loops. The first one is before the bottom end of slinky is going to fall, so its time the t is smaller than 1.364 seconds, and the two forces acted on the slinky before that time is the wave force and the tension force. So the net force is equal to the wave force plus the tension force, and according to Newton's second law, I updated the velocity and position of the slinky. And the second while loop is after the bottom end of the slinky fall, so it's during this time interval. And during this time interval, the two forces acted on the slinky is the wave force and the drag force. And according to the physics formulas, I added these two equations and also updated the velocity and position of the slinky. And when I run this program, we can get this graph. And based on the data I get from Tracker and GlowScript, I plotted this graph. So this is the comparison between the observation and the computational model. The orange line is the computational model and the blue one is the observation. These two graphs have the same trend, but there is a little divergence in the middle. This is because I marked the position of the slinky in Tracker by hand, so there are some differences, and also the motion of the slinky is too fast to mark very accurately. And the conclusion I get from this lab is that the bottom end of the slinky stays at rest until the top end touches it, and then the top end and the bottom end of the slinky fall to the ground together. And some improvements I can do is that I can track the data of the motion more accurately, or I can choose a more measurable object which has the same motion as the slinky. And that's all for my Lab 5. Thank you.